Welcome to this explainer. Today, we're taking on a genuinely fascinating mission. We are going to completely redefine what makes a snake the deadliest in the world. We constantly hear these wild claims about venom and danger, but what does the science actually say? Well, we're going to break down the true anatomy of danger, entirely separating laboratory chemistry from real-world geography, to find out which serpents are truly the most lethal on Earth.
Right, let's dive straight in by confronting a classic mystery. If you ask people what the absolute deadliest snake on Earth is, you're almost guaranteed to hear that famous rumor about the Belcher's sea snake, which is sometimes called the hook-nosed sea snake. For years, this idea just spread like wildfire in books and media. It was hailed as the undisputed king of venom, terrifying ocean swimmers, and totally dominating pub trivia nights. But is it actually true?
Well, it turns out this was a massive scientific mix-up. Prominent venom expert, Associate Professor Brian Greig Fry, actually debunked this whole myth. He explained that it all stemmed from a literal, fundamental error in a 1996 book called Snakes in Question. Basically, the authors mistakenly lumped all toxicity testing results together, totally ignoring how the venom was actually injected during the tests. As Fry brilliantly puts it, venoms can only be compared within a mode. Otherwise, it's apples and rocks. So yeah, a totally flawed testing comparison created a completely false champion.
Okay, so to avoid comparing apples for rocks, scientists actually use a standardized baseline for measuring toxicity, and it's called LD50, or median lethal dose. Simply put, this is the exact dose of venom per unit of body mass that it takes to kill exactly half of a group of test animals, which are usually mice. Now, the absolutely crucial thing to remember here is that a smaller LD50 value means the venom is way more toxic. Why? Because it takes less of it to be lethal. And for strict accuracy, scientists have to use standard matching injection methods, like subcutaneous, meaning just under the skin, to truly figure out which venom is the most potent.
So when we test properly, the true king of pure chemical lethality is finally revealed. It's the Australian inland taipan. Drop for drop, its venom is absolutely unparalleled, whether you're on land or at sea. It boasts an incredibly low subcutaneous LD50 of just 0.01 milligrams per kilogram. To put that kind of extreme toxicity into perspective, the maximum yield from just one single bite is enough to kill over 100 people, or, if you're counting, 250,000 mice. The data clearly shows it outpacing heavy hitters like the eastern brown snake and the coastal taipan by a massive margin.
But here is the absolute kicker, the incredible irony of it all. Despite possessing enough venom to literally wipe out a small crowd with a single strike, the inland taipan has killed exactly 0 people. Yep, 0. There's no way around it. This snake is just extremely shy and reclusive. It lives way out in the remote areas of central and eastern Australia. Honestly, the only bites that usually occur are when humans actively go out of their way to try and handle, photograph, or capture it.
And that brings us to a huge paradigm shift. Think about it. If raw toxicity doesn't actually equal death, how do we measure true danger? Because if the most toxic snake on Earth has a grand total death toll of 0, then clearly looking at LD50 alone in a sterile lab just isn't giving us the whole picture. We need to figure out a way to move past laboratory biology so we can evaluate actual, real-world danger.
To get that complete picture, we have to look at multi-factor systems, things like the Reptile Garden's Danger Quotient Matrix or the Human Lethality Index proposed by snakebite analysts. You see, these systems don't just hyper-focus on toxicity. They actually award points for real-world factors. Things like the snake's average size, the total venom yield it injects in a typical bite, and even the physical length of its fangs. But perhaps most importantly of all, they measure the snake's typical defensive disposition, basically how aggressive it is, and how many bites they actually inflict on humans per year.
And when you apply these real-world metrics, a brilliant contrast emerges. Take the inland taipan. Sure, it scores a perfect 5 out of 5 on toxicity, but because of its reclusive nature, it gets really low scores for disposition and bites, bringing its total to just 15. Now compare that to the saw-scaled viper found in Africa and Asia. It actually has a much less toxic venom, but it's highly aggressive, frequently encountered by humans, and it totally maxes out the threat scale in disposition and bites per year. It scores a whopping 23. In fact, some researchers argue this single species kills more people in Africa than all other venomous African snakes combined.
So, the crucial takeaway here is perfectly summarized by a snakebite analyst who was reviewing these human lethality indexes. They said, the most dangerous snake is the one that's just bitten you. And that hits the nail on the head, right? A hypertoxic snake living out its days sparsely in the middle of a remote desert simply isn't a realistic threat to your daily life. Real danger is a product of lethality multiplied by the actual likelihood of an encounter. Let's shift gears and look at the global epidemiology to really bring these stats home. Now, snake bites often go entirely unreported because they happen in deeply rural areas. But current estimates suggest that up to 94,000 people actually die from snake bites annually around the globe. And on top of that, hundreds of thousands more suffer permanent tissue damage and disability. That is a truly staggering human toll. And as we've just learned, it certainly isn't being caused by the shy little inland taipan.
These fatalities are actually highly concentrated. We're talking about an estimated 93 million people worldwide living in high vulnerability areas. The vast majority of envenomings occur in South Asia, Southeast Asia, and Sub-Saharan Africa. And why is that? Well, it's because these are the areas where humans and dangerous snakes share the exact same living and working habitats. A massive number of bites actually happen in industrial plantations. Banana plantations attract vipers, while rubber and palm tree plantations draw in elapids like cobras and mambas. It's essentially an occupational hazard where human agriculture directly overlaps with snake hunting grounds.
To really anchor this geographical reality, let's look at India. India suffers the highest death toll of any country in the world. We're talking at least 11,000 fatalities every single year. Historically, this massive toll has been attributed to what's known as the Big Four: the Russell's viper, the Indian cobra, the saw-scaled viper, and the common krait. These guys are just perfectly adapted to living in close proximity to human settlements. Interestingly, recent studies have also added the hump-nosed viper to this lethal list. It's a snake previously thought to be mostly harmless, but now it's recognized as being perfectly capable of delivering fatal bites that standard antivenoms in the region don't even always cover.
Let's turn our attention back to Africa for a moment to look at a snake that combines high toxicity with an absolute nightmare of a disposition, the black mamba. This is a highly territorial snake. It will actively defend an area of up to 2 square kilometers, and it's fast. It can move at incredible speeds of up to 11 kilometers per hour. But most terrifyingly of all, without antivenom, the mortality rate for a black mamba bite is 100%. Even with treatment, the mortality rate still sits at around 14%. It essentially has the highest mortality rate of any snake worldwide, proving that when you combine speed, aggression, and venom, you get something uniquely dangerous. The medical reality: surviving a lethal strike. Okay, so we've talked a lot about the statistics, but what actually happens to the human body during a severe snake bite? Let's take a look at the king cobra.
When a king cobra strikes, it can inject an absolutely enormous volume of venom in just a single bite. And because it delivers such a massive payload of neurotoxins, the systemic manifestations hit incredibly fast. Literally, within just 15 to 30 minutes, a victim can experience extreme drowsiness and a drooping of the eyelids, which is medically called ptosis. Fast forward just a few more minutes, and that venom can trigger catastrophic neurological failure that leads to severe respiratory paralysis. Without immediate medical intervention, envenomation from a king cobra can be rapidly fatal in as little as 30 minutes.
Because that clock is ticking so unbelievably fast, the immediate field response has to be intense, and it must be strictly followed. First off, ensure the snake is safely contained so nobody else gets hurt. Then you have to keep the victim completely calm and lying flat. That slows down their heart rate. Next comes the absolute most critical mechanical step. You must immediately wrap a large crepe bandage snugly around the bitten limb, working your way upwards. Now, this isn't just a loose covering. It needs to be as tight as you might bind a sprained ankle. That physical pressure actually retards the venom's absorption into the bloodstream. And finally, secure the whole thing with a rigid splint to immobilize the limb entirely.
Now, hospital survival hinges entirely on maintaining those strict protocols. Most importantly, and this is crucial, you must not remove those field bandages while in transit. Taking them off early can cause a sudden, deadly bolus release of venom straight into the system. Once the patient is actually in the emergency room, treatment relies on massive doses of paraspecific antivenom. For a king cobra bite, medical protocols actually often use tiger snake antivenom, and it can take anywhere from 8 to 20 vials for a moderate or severe bite. And since respiratory failure happens so fast, medical teams have to be completely prepared for immediate endotracheal intubation. Those field bandages? They are only removed very slowly over several minutes, but only once that antivenom is actively flowing through the patient's veins.
So, as we wrap up this explainer, we are left with a pretty fundamental, provocative question. Is a snake truly deadly just because it possesses the most perfectly evolved, highly toxic venom inside a laboratory test tube? Or is it deadly simply because it hunts in the exact same banana plantations and agricultural fields where we work and live? The data definitely shows us that while chemistry dictates lethality, it is geography, behavior, and proximity that truly dictate danger. It challenges us to completely rethink our fear of the wild. And honestly, it leaves you wondering, how many other deadliest things in the world are we measuring completely wrong?